All right, let's go on page 74 when we're done. And this is logarithmic function manipulation, which should be, it's the review from Algebra 2 for the most part. So since logarithmic expressions can also be written in exponential form, the same properties that apply to exponents can be applied to expressions involving logarithms. So what that kind of means is this. If I have x squared times x cubed, what does that give me? Not a trick question. X to the fifth. Okay. Because we're multiplying two terms, but we add the exponents, right? So there's a relationship between the multiplication and the addition. There's also a relationship in that with logarithms. It's a little bit of a different relationship, but still there's that connection. So we use these properties to manipulate logarithmic expressions to form equivalent expressions or equivalent forms. Those words come up a lot. AP loves that. Just different ways to write things. And it's good to have different forms of our expressions or equations because different forms can help us in different ways depending on what we're trying to do with it. So here are a review of our properties. Now, I adjusted these notes, but apparently grabbed my original when I did that because to me, there's too much written in here. I think there's value in you actually writing some of this down, but basically it's all filled in for you, but it's not the end of the world. We have the product property. So I have log base b, so my base is there, and then I have the argument there has two things multiplied together. I can split that into two logs with that same base, and instead of the arguments being multiplied, they'll have two logs that are added together. Does that make sense? That's your product property. You can also go the other way. So I could go this way, meaning if I have these two and I want to condense them, I have two logs that have the same base, and they're being added, so that becomes one log with the same base, and then I just multiply the two arguments there. Okay, does that make sense? That's how the product property works. So multiplication is connected to addition. So division or our quotient is connected to subtraction. So again, one single log with a quotient becomes two logs that are being subtracted. Numerator goes with the positive one, denominator goes with the negative one. Or we can go this way. So two logs with the same base, I get log base 3, and then these two numbers become a quotient. Right? That sound familiar? All right, so then I have my power property. Okay, I have, thank you, log base b of x to the n. So this exponent gets to come out front here. That's where we get n times log base b of x. Or again, we could go the other way. You have something out in front of your x. You can bring it up here as an exponent, and that's where we would get log base 7 of 3 to the x. Okay, those sound familiar? There's one thing that's, well, there's a couple, like not every single property is up here, but one I think that is important to remember. We did talk about it the other day, but it's been like, I don't know, a week and a half now. If I have log base b of b, so the base of the log and the argument are the same, that's going to give me 1. So if I have log base 7 of 7, that gives me 1. Okay. Everybody okay with that? So log base 30 of 30 is going to be 1. It doesn't matter what it is. All right, so we can use these properties to show various transformations. That's what we're going to connect this to with some transformations. But first, we're going to condense some. So our instructions say, write the equivalent expression by condensing each expression to a single logarithm. So let's see. So I've got two logs. You always check. Okay, we got the same base. That's good. So that's going to give me a single log that's base 4. And then since these two logs are being added, I multiply those two arguments like this. Now, I really need parentheses here because it looks like what I'm trying to say is log base 4 of x times y. But who's to say it's not log base 4 of x times y? You see how those would be different? So we put parentheses here just to be very clear. And it's fine to put parentheses, like even like here, if I just have one little thing. I think we just don't a lot because it just gets to be a lot. So basically, if there's anything besides just like a single number or a single variable, then we usually put parentheses just to make everything clear. All right, so then I've got two logs, same base. So this is going to become log base 3. Now this is subtraction, so I'm going to get a quotient, and it's going to be 5 over z. Any questions about where anything's coming from? All right. So then we have 3 terms here. Now, technically, we should do it 2 at a time. So that's what we're going to do on this first one. And then I'm going to tell you how you really just do it all at once and don't overthink it. Because the overthinking and the stepping through rules on this is what causes us to do weird things sometimes. But I do feel like I have to at least show you how to do it properly. So I'm just going to look at these 2. So I'm being subtracted. So this is going to give me log base 10 of x over 5. And then I still have minus log base 10 of z. Do I really need that 10 there? No, but if they give it to me like that, then I think I'm just going to leave it there. Like, it wouldn't be wrong to drop it, but again, sometimes they'll give it to you. It's just weird to me. I don't know. So now I have 2 terms to deal with, and same base, so I'm going to get log base 10 again. And then I'm going to have to put x over 5 over z. But really what I'm doing is I'm just also dividing by z. So it ends up in the denominator like this. When you're condensing them, I don't see as many issues as if we go from here back to here. That's where I see a whole lot of signs end up being wrong sometimes. And that has to do with parentheses and some other things. So instead of overthinking it, and yes, we have rules and we can get it there, but if you know you're going to have multiplication or division of some sort, then you go ahead and set up your little, fraction bar. And then here, this log is positive, right? So since x is attached to a positive log, it goes in the numerator. Anything attached to a negative log goes in the denominator and gets multiplied. That's the easiest way to do it. Positive log numerator, negative log denominator, and just multiply them. Okay. Otherwise, sometimes we'll get things backwards. And that's when you start to overthink it. And do I need my parentheses? And we don't need to do all that. Okay. Just kind of a little shortcut. Everybody good so far? All right. So on D, now on those 3, I just jumped into, hey, we're going to condense. But I can't just condense this right now because, yes, I had 2 logs, but I got this 3 out here. I got to take care of him first. So what can I do with that 3? What can it become? An exponent. Good. It's your power rule, right? So just like if it was x to the 3rd, I could bring it out front. It can go back up there. So this is going to give me log base 2 of x cubed minus log base 2 of y. And now that I have log and there's no coefficients, now I can combine them. So I've got log base 2. X cubed is with a positive log, so it's in the numerator. Y is with the negative log, so it's in the denominator. And there you go. Okay, everybody good so far? All right, now let's look at E. What do I need to take care of first? The 2 and what? The 5. Good. So this is going to give me log base 7 of a squared. Now that's a minus 5, but I leave the minus here and the exponent is positive. So minus log base 7 of b to the 5th plus log base 7 of 4. Go ahead and see if you can condense that without overthinking anything. All right, you ready for me to talk you through it? A squared is on a positive log. It goes in the numerator. B to the 5th is on a negative log. It goes in the denominator. 4 is on a positive log. It goes in the numerator. See how easy it is to put that stuff together? Any questions at all? Okay. So the reason I've been able to condense these is because I have 2 logs, or 2 or 3, with the same base. On F, I have a constant and a log. Now these instructions said, do this by condensing each expression to a single logarithm. It doesn't say if possible. It says do it. So that means that I need to take this 2 and I need to change it, put it in an equivalent form that is a logarithm. Okay, so that means I want, and not only a logarithm, but I need it to be base 6 so they match. Does that make sense? So I'm not rewriting this. I'm just kind of taking the 2 out for a minute and say 2 equals log base 6 of something. I don't want to use x though because it's there and that would be very confusing. So I'm just going to use y just to have another variable, right? So I can rewrite 2 as a log base 6 of something. I got to figure out what that something is. So I can rewrite this as an exponential. If I do that, what's the base of the exponential? 6. So this would be 6 to what power? It's good. 6 to the second power equals what? Y. So that means that y equals 36. Okay, so what we have just figured out is that 2 is equal to log base 6 of 36. Okay, just a different way to write the number 2. Just like 2 is also 6 divided by 3. 2 is also the square root of 4. Like it has a lot of different forms, right? So let me show you why this works here. So we have log base 6 of 36. So I'm going to rewrite that as log base 6 of 6 squared. Do you agree that those are equal? Okay. So now I'm going to use my power property and bring this 2 out front. So this is going to give me 2 times log base 6 of 6. What's log base 6 of 6? 1. And 2 times 1 is 2. So it's just a more complicated way to write the number 2, right? But by doing that, I can now condense these. So let me go back down here then. So now I'm going to take this and basically substitute it in where that 2 is. So that I have log base 6 of 36 plus log base 6 of x. Now I have 2 logs with the same base. I can condense them and I get log base 6 of what? 36x, exactly. Okay, everybody good with that? Any questions? All righty. Then I'm going to give you a minute and I want you to work example 2. Okay, can I start by bringing that 2 out in front? What do you think? All right, so if you already have work here, which you might, just write what I'm going to write somewhere that you can make it fit. I want you to write that log base 3 of x squared over y does not equal 2 times log base 3 of x over y. Can anybody tell me why I can't start by moving the 2? Right? I can't just say, oh, this 2, he's just going to plop out in front. Say what? Because it's inside the parentheses, right? So what is that 2 being applied to? X. Does it have anything to do with the y? No, it does not. And so that's why you got to be careful willy-nilly taking this stuff out. Because if I did that, like if it was equal to that, then that's actually what gets you to answer B, which is not the answer choice. And you have to have parentheses the whole 9 yards. Now, if it was x over y squared like that, then I could. You see the difference there? So I just want to make sure and point that out and so that you understand the differences. We good on that? Okay. So you may or may not have made that mistake, or you may not have even thought about it until I said something, but because I see weird things like that sometimes, make sure you are using the exponents at the right time. So instead, what I can do is I've got this quotient, so this can be log base 3 of x squared minus log base 3 of y. Now can I bring the 2 out front? Now it's legal. It comes out front right here, and that's where I get C from. Any questions at all? Okay, so there's different ways to approach multiple choice questions, and sometimes it's a good idea to look at your answer choices, see if you can eliminate anything obvious, but instead of just trying to look at this and match it up with one, just do what you know how to do. Otherwise, you get lost in here sometimes, and that's kind of where you fall into traps too. That's what happens there. All right. So example 3, the function f of x equals log of 6x is a horizontal dilation of the function g of x equals log of x. So whether or not they told me that horizontal dilation part, we know that. Not because we are experts at logs, because maybe we're not, but we should be experts at transformations by now. If I've got a number multiplied by x, I don't care what kind of function it's in. That's a horizontal dilation, right? And would that 6 be a stretch or a compression? What does x do? He's a liar. He lies, right? So that means that 6 is a compression. You started to say, and you're like, I don't want to say compression. So it's a compression, right? And we know that. We don't have to know what the graph looks like, but we understand what's going on, whether we get the logs or not. Okay, so it says to show that f can also be written as a vertical translation of g, looking like that, where k is a constant. So basically with logs, every horizontal dilation can be rewritten as a vertical translation. It's just the nature of the graph, and it's kind of weird how that works. So I'm just going to rewrite that first. F of x is equal to log of 6x. Okay. And then I'm going to use my log properties that I know, and that's going to become log of 6 plus log of x. Do we agree with that? Okay. Now I have, so I'm going to bring down my f of x equals, I'm going to bring down my log of 6. What's the base on this log? 10. Very good. And then, but I'm not going to bring down my log of x. What does log of x equal in this question? G of x, exactly. Log of x is g of x, right? So I can substitute in g of x for that. Everybody okay with that? Because this is what we're trying to get to. And we're almost there. I just have to flip it around and say f of x is equal to g of x plus the log of 6. And log of 6 is just some number. I don't know what it is. It's like the square root of 17. I have no idea. But if I had to figure it out, I could use a calculator and figure it out. So that's where this, since I'm just adding a constant here, that's my vertical translation. Okay, we good with that? What questions you got? Okay. So now we're going to look at the change of base property. Okay, but we're going to go back here for just a second. I want to show you something. When we add this quotient property, okay, let's say we're going this way. I have 2 logs that gets condensed to 1 log with division in it, all right? That is different than what we're about to do, okay? 1 log with division, because your change of base property, we have division, but it's log over log. You see how those are different? They're 2 completely different things, so we just want to make sure we have them separated in our brain. That little video I showed you about logs, which again, it's been like a week and a half now, it quickly mentioned the change of base property. It basically said, most calculators have the log button, basically base 10. And so we could use change of base property so that we can find the log of anything on a calculator. Kind of made it sound like you can't find the log base 7 of stuff on a calculator. Even on the calculator, they showed you can. It's just sometimes hidden in the menus. It's a lot easier to get to on most newer calculators. And then with Desmos, it's even easier than that just to type it in. But there are other reasons why you might want to change the base. So it's not all about just being able to punch it in the calculator. So here's the way this works. I have, well, let's just say we're trying to do it log base 10 for old school calculators. I have log base b of x. I can change this to log base 10 of x over log base 10 of b. And as long as these 2 match, it could be literally any base I wanted it to be. Okay, so again, we can change it for lots of different reasons to be able to maybe substitute in or things cancel out. It just depends on what you're needing to do. So here's example 4. It says, let f of x equal log base 4 of x, g of x equal log base 9 of x. Show that f is a vertical dilation of g. So when you change the base, you get a vertical dilation. Okay? Again, just the way that these work. By finding the value of k, such that this is true right here. So I'm again going to start by just rewriting f of x. F of x equals log base 4 of x. Now I need to relate this to g of x. And I can't condense or anything on this because it's just a single log, but I have its change of base formula. And if I do a change of base and I'm trying to relate this to g, what do you think I want my new base to be? 9, right? It's kind of the only thing that makes sense. So that means this is going to equal a quotient of 2 logs base 9. Okay, log base 9, log base 9. Could be log base anything. Then the argument goes in the numerator, and the base goes in the bottom, like so. Okay. And this is the form I want with multiplication. I have division. I can very easily change that to multiplication by making this 1 over log base 9 of 4 times log base 9 of x. Right? Because if I took this and went this way, that's what I would get back. Everybody okay with that? So here then, bring down my f of x. That's equal to, bring this down, 1 over log base 9 of 4 times, what is log base 9 of x? G of x. And now what I have written in that light pink color matches this. Now on that last question, we left it like that because it was asking me just to show that that happened. This one's asked a little bit differently, so you got to pay attention to how things are asked. We've done all the work. It didn't say just show me this. I mean, it does say show it, but it says by finding the value of k. Have I found it? Well, okay. Have I said that I found it? No, but have I found it? Like this is my, isn't this my k right here? Yeah. So I just need to say that I found it. Basically, I know I didn't answer the question. I didn't ask the question very well. But like just having it there, that's not good enough. I need to say that I understand that k is equal to 1 over log base 9 of 4. And again, that's just, well, sorry, I've gotten so used to not boxing in them. And again, that's just some value, it's just some constant. I have no concept of what that is, and that's okay. Everybody good so far? Yes? All right. All right, so natural logarithm, we're going to talk about this again. So remember, this is a lowercase l n. It is not a capital I n. Think of it as log natural. And what we know about natural logs, okay, the base is e. So it's basically log base e of x equals the natural log of x. You will never, even though they put the base 10 on some things, it's never going to be written like that, except when you're explaining it. And for some reason, and I think it's just because you haven't used them as much as the other logs, and you haven't even used those that much, but people want to make them real hard. And there's something we say over and over again in calculus, which is E means easy. Anytime E means easy. So it doesn't make it more hard, or more difficult. If I have, so let's just say I have log of x, and I need a picture of that in my head. It looks something like that, right? But better, but whatever. And that could be, that's base 10 is what I wrote. But whether it was base 3, base 20, it doesn't matter. I don't have a scale, so it's basically that shape, right? Natural log of x, it looks exactly the same. Because e, which is the base, is about 2.717, right? So it's just another number here that's greater than 1. So these, even though mine may look a little bit different, they are supposed to look exactly the same. That's the picture you have in your head. And what's this x value that they go through? 1. It's 1 on all of them. Okay. Everybody good with that? Okay. So knowing that, just because it's a natural log doesn't make it any more difficult. All your log properties work. I'm going to give you a minute, and I want you to do example 5. What do I have to take care of first? 3 and the 4, right? So I'm going to get natural log of x cubed minus natural log of y to the 4th. Now, if you like C as an answer, don't raise your hand because you're wrong, okay? But I think C is on there as an answer choice to see if you have any concept of what you're actually doing. Because the way I would get from here to C would basically be to factor out the natural log. Can you factor out a natural log? No, because it's not multiplication, right? So nice try, but we're not falling for that. Because if I was to factor it out, that would mean that natural log by itself makes sense, which it doesn't. It's just like a random square root sign. Like what? Square root of what? I don't have anything. So can't do that, but again, nice try. But I do have 2 logs with the same base being subtracted I fixed my exponents, my answer is A. Okay, we good on that? Any questions at all? Awesome. I don't know, let me see. Oh my gosh, what the heck. Where did I get what now? Uh-huh. Okay, so this right here is equal to these two things multiplied together. So if I put that over 1, do you see when I multiply it back together, I get that? So dividing by something is the same as multiplying by 1 over that thing. So if I have, let me just make it simpler here. If I have 3 halves, isn't that the same thing as 1/2 times 3? That's what I did. It just looks yucky because of the logs. Does that make sense? Okay, good question. Thank you for asking. Thank you for, I know sometimes I'm begging for questions and then you have a question, I'm not even paying attention to you. Anything else? Okay, sometimes you gotta holler at me.